Students, welcome to my YouTube channel. Today we are going to do quiz number 8 for the month of January. This quiz will contain questions from Net, Nav, Rex, Tech, Radio, Telephony, etc. This quiz is intended to boost your preparation for airline exams or any other exam that you are taking. So all the best, and let's begin with question number 1 for today. Aircraft is 60 miles from a VOR station. It has a CDI indication of 1/5 deflection. This represents a coarse centerline deviation of approximately how much? So here we have a VOR station. This is the radial of that VOR. An aircraft has traveled 60 miles away from that station. So aircraft has traveled 60 miles away from that station. The CDI indication shows a 1/5 deflection. That means our aircraft, instead of being positioned exactly on this radial of VOR, it has deviated from that radial and is somewhere over here. Okay, on some other radial of this VOR. We have to find out. We have to find out the distance. Okay, this deviation distance from the main course. This was a main course or track. By how much distance have we deviated from that track? So this is called distance off track. This is distance gone. The track error between them is how much? The angular error. Now here they have told you the CDI is showing 1/5 deflection. That means this is your OBS selector. Okay. This is the center dot. There are 5 dots on either side. 5 dots. 5 other dots on either side. Okay. And CDI is showing 1/5 deflection. 1/5 of total deflection. Now the maximum deflection that CDI needle can show is maximum is 5 dots. Is 5 dots. 5 dots right or 5 dots left hand side. So out of that total 5 dots deflection, it is currently showing 1/5 deflection. So 1/5 times maximum 5 dots is how much? 1 dot. Now in case of 5 dot indicator, 1 dot is equal to 0.5 degree. Correction, 1 dot equals to 2 degree. 1 dot equals to 2 degree. If you are dealing with VOR, in VOR 1 dot will be equal to 2 degree. In case of localizer, 1 dot will be equal to 0.5 degree. Okay, so this is a VOR sum, so 1 dot will be equal to 2 degree. So 1/5 deflection means 2 degree deflection from the original track. So this angle is, track error angle is 2 degree. So let's use the formula. Track error angle equals to distance of track upon distance gone into 60. Track error is 2 degree. Distance of track we have to find out. Distance gone is 60 into 60. Therefore, distance of track will be equal to how much? 2 nautical miles. So this is 2 nautical miles. So you have deviated from the track by 2 nautical miles. Option B is the correct option. Question 2. How many feet you have to climb to reach flight level 75? The airport elevation. So let's draw this. This is your airport. Elevation of airport from mean sea level is 1500 feet. The elevation of airport from mean sea level is 1500 feet. Cruising altitude is flight level 75. Now all flight levels are measured from standard pressure setting. Now standard pressure setting is 1013. The pressure existing at mean sea level is QNH, which is 1023. Our cruising altitude is flight level 75. Okay, flight level 75. So we have to take off from this airport, which is at an elevation of 1500 feet, and go towards altitude flight level 175. Go at altitude flight level 175 vertical distance. So how much we have to climb? How many feet you have to climb? So you have to climb a total of this many feet, starting from the airport to this flight level 75. You will have to climb from the airport to this level and cover this much vertical distance. Now we know flight level 75 is this much. 75 is measured from standard pressure setting 1013. Okay, so this entire thing is how much? This entire thing is flight level 175. Correction, flight level 75. Okay, this entire thing is flight level 75. Out of that, out of that, we will first find out this. Flight level 75 is made of this part and this part. Now we want to find this part, question mark part. To find out that from this entire thing, we will have to eliminate this thing. We can eliminate this portion by finding out this small portion existing between two pressure levels. So now I am writing here, the difference in these two pressure levels is 10 millibars. Now 1 millibar always produces a height difference of approximately 30 feet. So 10 millibar will be equivalent to 300 feet. So this is 300 feet. 300 feet. Now the entire thing is 1500. Out of that 1500, this small portion is 300. So the remaining portion will be 1200. 1200. So next final conclusion, altitude aircraft has to fly from airport to cruising altitude equals to 7500 feet minus 1200 feet, which is equal to 6300 feet. So aircraft will have to fly a total of 6300 feet, a total of 6300 feet. Okay, this total was 7500. Out of that we eliminated this and we got 6300 feet. That is how much we have to climb from ground to that level. So 6300. Let's go to next question. Is true regarding flight operations in class A airspace. Now class A airspace, okay, has many properties, like only IFR flights are allowed in permitted in class A airspace. You should have a working transponder with mode C capability, a functioning radio equipment, DME equipment, etc., etc. So let's check the options. Aircraft must be equipped with approved distance measuring equipment. Aircraft must be equipped with an ATC transponder and altitude reporting capability. May conduct operations under VFR. So not at all. You cannot conduct VFR operations in Class A airspace. Option B is the correct option. You must have a working ATC transponder with Mode C capability. Option A may be right if you are going to use DME above flight level 240, 24,000, 25,000 feet along with VOR in that case. So option A can be eliminated as of now, and option B is the most Option B is more proper than option A. Question 4. Light beacons producing red flashes indicate what? Now red, they're talking about red flashes, not a steady red light, but red flashes. So they indicate ATC, ATC gun signals, that is ATC light signals. So when you are receiving ATC light signals on ground and in air, they have different meanings. Now let's focus our attention to red flashes. Now red flashes is this. Now when you are receiving flashing red light from ATC and you are on ground, that means taxi clear of runway in use. When you receive red flashes in air, that means airport is unsafe, do not land, continue circling. Okay, airport is unsafe, do not land, continue circling. So the correct option will be option A says end of runway warning at departure end. So that is wrong. End of runway is marked by red light, that is true, but not by red flashing lights, but red steady red lights. Okay. B is a pilot should remain clear of airport traffic and continue circling. So that is correct. So option B is the correct option. Obstructions or areas considered hazardous. So that is also wrong. Now whenever you fly, whenever you start flying, you will notice red color beacons or red color lights on top of tall buildings, high obstruction towers, etc., etc., mountains. So they have red lights, and these red lights are more clearly visible during night flying. Okay, so these red lights are there to attract attention of pilot to those high altitude or high vertical distance obstructions. Okay, and these lights are steady red lights, not flashing red lights. They are steady red lights. So option C is also eliminated. Question 5. During winter months in the mid latitudes, the jet stream shifts towards where? North, south, and what happens to their speeds? Now, during winter months, always remember, during the winter months, let's say this is your country, India. Okay, during the months of winter, the jet stream moves, the jet stream moves southwards. The jet stream moves southwards. Okay, during winter months, the jet streams move down the latitudes. During summer months, okay, during summer months, the jet streams will move up the latitudes towards northern hemisphere or towards north pole. So during winters towards south pole, during summers they move towards north pole or they migrate to higher latitudes. During winters they migrate towards lower latitudes. So that is the answer. So during winter months they will migrate south and the speed increases. So always during winters the speeds of jet streams are much more than speeds during summer months. So option B is the correct option. The strength and location of the jet stream is what? So the strength is weaker in the summer, that is right. Stronger in the winter, that is also right. Stronger in the summer, so that is wrong. So between option A and B. Location, let's check the location. They say option A says the location of jet stream is farther north in the summer. The location of the jet stream is farther north in the winter. So option B is eliminated. Option A is the correct option. Summer months, jet streams migrate at higher latitudes. During winter months, the jet stream will move southwards. Okay, so option A is the correct option. On which principle does VSI, vertical speed indicator, work? So vertical speed indicator works on the principle of static pressure, comparison of static pressure. So on the principle of difference in static pressure, yes. On the principle of difference in barometric pressure, on the principle of pitot pressure. So option A is the correct option. B and C are eliminated. Barometric pressure is the pressure measured by barometer. Barometer is a pressure reading instrument. Okay, so VSI is not concerned about barometric quantity. Altimeter is, but so the more proper option will be option A. It works on the principle of difference in static pressure, not barometric pressure. Question 8. Heading indicator, turn coordinator, attitude indicator are classified as gyro instruments, engine instruments, vacuum instruments, pressure instruments. So now here the most appropriate answer is option A, gyroscopic instruments. Engine instruments are your tachometer, that is RPM indicator, oil pressure, oil temperature, cylinder head temperature. These instruments are engine instruments. Vacuum instruments. Now, heading turn coordinator work, they are gyroscopic instruments, but they can also be called vacuum instruments as the power to run them is derived from vacuum. But here the option also states about turn coordinator. Now turn coordinator works on electricity. Okay, so we cannot classify all three as vacuum instruments at same times. Had the question not included turn coordinator, we could have selected option C, vacuum instruments. But now we have to select an option which is suitable for all three instruments. And option A is the correct as far as it is concerned about gyroscopic instruments, not vacuum instruments. Delta pressure instruments are your altimeter, airspeed indicator, vertical speed indicator. So with this, we come to the end of this lecture. I hope you have understood the 8 questions that we have done today, and there is some revision happening as you do this mixture of questions from different subjects. We tend to always focus on one subject at one time, and if any other question comes from any different topic, we tend to spend timing thinking or recollecting things from our memory. So also having a practice of solving mixed questions, it increases our speed of thinking and also prepares us for airline exams when we expect different questions from different topics together. So do hit the like button if you have liked this lecture, subscribe to the channel if you haven't, and share this video with all your friends. Keep learning. All the best.